ABCD parameters or transmission parameters of two-port circuit. The equations for ABCD parameters are V1 equal to A V2 minus B I2. This is first equation. Second equation is I1 equal to C V2 minus D I2. Now we can write these equations in the form of matrix V1 I1 on the left hand side, and then A B C D 2 cross 2 matrix, and V2 I2 with negative sign. This is transmission matrix or ABCD matrix. Now here A is ratio of V1 to V2 when I2 is 0 or port 2 is open circuited. This is the ratio of two voltages, so it is unitless quantity, and it is called reverse voltage gain. Reverse voltage gain when port 2 is open circuited. Why it is called reverse voltage gain? Because it is the ratio of voltage of input port to output port, or voltage is transferring from output port to input port. That's why it is reverse voltage gain. And then B is V1 over minus I2 when V2 is 0. V2 is 0 means port 2 is short circuited. It is the ratio of voltage to current, so its unit is ohm, and it is called reverse impedance. Reverse impedance because it is the ratio of voltage of input port to the current of output port, or resistance is transferring from reverse transfer impedance because impedance is transferring from output port to input port. In the equation 1 and 2, there is a negative sign here because in transmission we assume that current is coming from left to right side. So current in the output port also going from left to right. It means current should go towards the load. That's why the sign of I2 is negative here. Now the C is I1 over V2 when I2 is 0 or port 2 is open circuited. Its unit is mho, and it is called reverse transfer admittance. Because it is the ratio of current of input port to the voltage of output port, or the admittance is transferring from output port to input port, and D is I1 over negative I2 when V2 is 0 or port 2 is short circuited. It is the ratio of current, so it is unitless quantity, and it is called reverse current gain. Why it is called reverse current gain? Because it is the ratio of current of input port to the current of output port, or current is transferring from output port to input port. Now, can we draw the equivalent circuit for these two equations? It's a trivial question, and as far as my knowledge is concerned, we cannot draw the equivalent circuit for equations of ABCD parameters. Now let's make the conversion of ABCD parameter. In fact, let us write Z parameters in terms of ABCD parameters. Equations for Z parameters are V1 equal to Z11 I1 plus Z12 I2. This is first equation. Second equation is V2 equal to Z21 I1 plus Z22 I2. Equation for ABCD parameters. First equation is V1 equal to A V2 minus BI2. And another equation is I1 equal to CV2 minus DI2. Now we will have to modify equation 3 and 4 in the form of equation 1 and 2. See here equation 2 has V2, I1 and I2, and equation 4 has also V2, I1 and I2. So we'll reshuffle the equation 4 in the form of equation 2. So I1 plus DI2 equal to CV2, or we can write V2 equal to 1 over C I1 plus D over C I2. This is equation 5. Now let's compare equation 5 with equation 2. This will give Z21 equal to 1 over C, and Z22 is D over C. Now let us substitute V2 from 5 to equation 3. So V1 is A over C I1 plus AD over C I2 and then minus BI2. So V1 is A over C I1 plus AD minus BC over C I2. This is equation 6. It has V1, I1 and I2. Equation 1 has V1, I1 and I2. So let's compare equation 1 with equation 6. This will give Z11, which is equal to A by C, and Z12 is AD minus BC over C. And here AD minus BC is nothing but the determinant of transmission matrix or ABCD matrix. So that's how we write Z parameters in terms of ABCD parameters. Now let us write the condition for a reciprocal two-port network or reciprocal two-port circuit. For a reciprocal two-port circuit, V1 over I2 when I1 is 0 must be equal to V2 over I1 when I2 is 0. Or in terms of Z parameters, it is Z12 must be equal to Z21. Now we will replace Z12 and Z21 in terms of ABCD parameters. So Z12 is AD minus BC over C, and Z21 is 1 over C. So this will give AD minus BC equal to 1. This is the condition for reciprocal two-port network in terms of ABCD parameters. Now symmetrical, we will write the condition for symmetrical two-port network or two-port circuit. For symmetrical two-port network, condition is V1 over I1 when I2 is 0 must be equal to V2 over I2 when I1 is 0. In terms of Z parameters, it is Z11 must be equal to Z22. Now we will replace Z parameters in terms of ABCD parameters. So Z11 is A over C and Z22 is D over C. So this will give A equal to D. So this is the condition for symmetrical two-port circuit in terms of ABCD parameters. Now let us find out the ABCD parameters for this two-port network or two-port circuit. Now, equations for ABCD parameters are V1 equal to A, V2 minus B I2, first equation. Second equation is I1 equal to CV2 minus DI2. Now we have to write two equations for this two-port circuit by applying KVL and KCL, and the two equations must be in the form of equation 1 and 2. So let us apply KVL in this loop. So rise in voltage, minus 2 plus rise in voltage V1, then drop across, in fact rise in voltage across R, it is RI2, and then drop V2. So V1 is V2 minus RI2. This is equation 3. If we compare equation 3 with equation 1, then A is 1 and B is R and unit for B is ohms. Now from the circuit we can see that I1 is negative I2, or this equation can be written as I1 equal to 0 V2 minus 1 I2. This is equation 4. Now let us compare equation 4 with equation 2. This will give C 0 and D equal to 1. So D is unitless quantity and C is admittance, so its unit is mho. So ABCD parameters or ABCD matrix is 1R01. Now let us find out the ABCD parameter for this two-port network. Again, by applying KVL and KCL, we have to write two equations in the form of equation 1 and 2. So here we can see that this path is short circuited, so V1 is equal to V2. Let's rewrite this equation. V1 equal to 1 V2 minus 0 I2. So this is equation 5. It has V1, V2 and I2. Equation 1 has V1, V2 and I2. So comparing 1 with 5, this will give A equal to 1, which is unitless quantity, and B is 0 ohms. Now current through this resistance R is I1 and I2. So apply KVL in this loop. Rise in voltage V2 and then drop across R is RI1 plus RI2 equal to 0. So RI1 is V2 minus RI2. So I1 is 1 over R V2 minus 1 I2. This is equation 6. Now let us compare equation 6 with equation 2. So C is 1 over R, its unit is mho, and D is the ratio of current, so it is unitless quantity and its value is 1. So ABCD matrix for this two-port network is 1 0 1 over R, 1 over R and 1. So that's how we find the ABCD parameter for the two-port circuit. Now let us do the analysis of terminated two-port circuit. Analysis of terminated two-port circuit. This is two-port circuit, and we have the information of ABCD parameters of this two-port circuit. And two-port circuit is terminated at load ZL. And at input port, external source with voltage VG and impedance ZG in series is connected. Voltage at port 1 is V1, current is I1, voltage at port 2 or output port is V2, current is I2, and current through load is IL. This voltage is V0, this voltage is Vi, and this is input current. Now for this circuit, we have to find out current gain, in fact input impedance Zi, which is V1 over I1, output impedance Z0, which is V2 over I2 when Vg is 0. We will also find out current gain, which is IL over II or negative I2 over I1, and the voltage gain V0 over Vi or V2 over V1. We will start with this input impedance, but first let us write the equation for ABCD parameters. So V1 is A V2 minus B I2. This is equation 1. Second equation is I1 equal to C V2 minus D I2. Now from the output side we can write V2 as negative ZL I2. This is equation 3. For input impedance, we need to have the ratio of V1 to I1. So V1 over I1. So let us replace this V2 from equation 3 to 2. So I1 is negative CZL I2 minus D I2. So I1 is negative I2 into D plus CZL. So this one will give negative I2 over I1, which is the current gain, and it is 1 over D plus CZL. This is the expression for current gain. Now this is equation 4. Now from equation 4, replacing I2 to equation 1. Okay, first replace V2 from equation 3 to 1. So this is V1 equal to negative A ZL I2 then minus B I2. So V1 is negative I2 into B plus A ZL. And we know that minus I2 is I1 over D plus CZL from equation 4. So replacing minus I2 from equation 4 to this equation. So V1 is B plus AZL over D plus CZL into I1. So input impedance, which is V1 over I1, is B plus AZL over D plus CZL. This is the expression for input impedance. Let us assume that this is equation 5. Now we have to find the voltage gain, which is V2 over V1. So now we know that V2 is negative ZL I2, and what is V1? V1 is Zi into I1. So here negative I2 over I1 is AI. So AV or voltage gain is ZL over Zi into AI. This will give the expression for voltage gain. Now we have to find out the output impedance. So let us redraw the circuit. For output impedance, we need to remove this load ZL because output impedance is the impedance of the circuit looking from the output port. So no need to keep the load impedance. At the same time, we have to make the external source, external independent source 0. So VG is short circuited. Now, to activate the dependent sources of this two-port circuit, we need to apply an external source in place of load with voltage V2 and the current I2. So this Z naught is V2 over I2 when VG is 0. We know that the equations for two-port networks in terms of ABCD parameters are V1 equal to A V2 minus B I2. This is first equation. Second equation is I1 CV2 minus DI2. Now from the input side, we can write V1 equal to minus ZG I1. This is equation 3. So we have to find out the ratio of V2 to I2. So replacing this V1 from 3 to equation 1. So minus ZG I1 equal to AV2 minus BI2. So I1 is A ZG with negative sign V2 plus B ZG I2. Now we will replace this I1 from equation 4 to equation 2. So this is minus A ZG V2 plus B ZG I2 equal to CV2 minus D I2. So this is B over ZG plus D I2. On the right hand side, we have C plus A ZG into V2. So this is B plus D ZG over ZG I2. On the right hand side, we have A plus C ZG over ZG V2. So these two ZGs are cancelled out. So Z naught, which is V2 over I2 when VG is 0, is equal to B plus D ZZ over A plus C ZZ. So that's how we find out the expression for output impedance. For this two-port network, we have to find out the ABCD parameters. So equations for two-port network in terms of ABCD parameters are V1 equal to A V2 minus BI2. This is first equation, and second equation is I1 equal to CV2 minus DI2. Now by applying KVL and KCL, we need to write two equations in the form of equation 1 and 2. Okay, so the current through this 20 ohm resistance is I1 plus I2. Now let us apply KVL in this loop. So minus to plus rise in voltage V2, and then drop, in fact rise in voltage minus to plus rise in voltage 3I1, and then drop across this 20 ohm resistance, which is minus 20 I1 plus I2 equal to 0. So V2 plus 3I1 minus 20I1 minus 20 I2. So V2 minus 17 I1 minus 20 I2 equal to 0. So it is 17 I1 equal to V2 minus 20 I2. So I1 is 1 over 17 V2 minus 20 over 17 I2. This is equation 3. Now this equation has I1, V2 and I2. Equation 2 has I1, V2 and I2. So now let's compare equation 2 with equation 3. This will give C equal to 1 over 17 mho and D is 20 over 17. Now we have to write another equation in the form of equation 1. So let us apply KVL in this path. Minus to plus, rise in voltage V1 and then drop across 10 ohm resistance is 10I1 and then drop 3I1 and then drop V2 equal to 0. So V1 is 13I1 minus, in fact 13I1 plus V2. So now let's replace I1 from equation 3 to this equation. So V1 is 13 over 17 V2 minus 13 into 20, which is 260 over 17 I2 and then plus V2. So this V1 is 13 over 17 plus 1 into V2, which is 13 plus 17 over 17, and 13 plus 17 is 30, then over 17 V2 minus 260 over 17 I2. So this is equation 4 and it has V1, V2 and I2. Equation 1 has V1, V2 and I2. So now let's compare equation 1 with equation 4. This will give A equal to 30 over 17 and B is 260 over 17 ohms. So that's how we find the transmission parameter or ABCD parameters for the given two-port circuit. Now the second example, for the given two-port circuit we have to find out the transmission parameters or ABCD parameters. So equations for ABCD parameters are V1 equal to A V2 minus BI2. This is first equation. Second equation is I1 equal to CV2 minus DI2. Now we have to write the two equations from this circuit in the form of equation 1 and 2 by applying KVL, KCL. So current coming from the terminal 2 is I2 and this current is 3I1. So current through 1 ohm resistance is sum of these two currents. So I2 plus 3I1. Now from the port 1 I1 current is coming. So current through 2 ohm resistance is sum of these two currents. So current through 2 ohm resistance is I1 plus 3I1, that is 4I1 plus I2. So I2 plus 4I1. Now let us apply KVL in this loop. So rise in voltage V2, then drop across 2 ohm resistance is 2I2, Then drop across 1 ohm resistance is negative I2 plus 3I1, and then drop across 2 ohm resistance is 2I2 plus 4I1. So V2 then minus 2I2, negative I2, negative 3I1, negative 2I2, and then negative 8I1. So V2 and then minus 2 minus 1 minus 2. So minus 5 I2, and then minus 3 and minus 8 minus 11 I1. So 11 I1 is V2 minus 5 I2, or I1 is 1 over 11 V2 minus 5 over 11 I2. This is equation 3. It has I1, V2 and I2. Equation 2 has I1, V2 and I2. So now compare equation 2 with equation 3. This will give C equal to 1 over 11, and its unit is mho, and D, which is the ratio of two currents, and its value is 5 over 11. Now we have to write another equation in the form of equation 1. So let us apply KVL in this KVL in this loop. So minus to plus, rise in voltage V1 and then drop across 3 ohm resistance 3I1, then drop across 2 ohm resistance 2 into I2 plus 4I1. So this is V1 minus 3I1 minus 2I2 minus 8I1. So V1 minus 11I1 minus 2I2 equal to 0. So V1 is 11I1 plus 2I2. Now we can replace 11I1 from this equation to the present equation. So it is V1 equal to V2 minus 5I2 plus 2I2. So V1 is V2, and 2 minus 5 is minus 3I2. This is equation 4, and equation 4 has V1, V2 and I2. Equation 1 has also V1, V2 and I2. So now let's compare equation 1 with equation 4. This will give A equal to 1, which is ratio of two voltages, so unitless quantity, and B is 3, and its unit is ohm. So the ABCD parameters or ABCD matrix for the given two-port network is 1, 3, and then 1 over 11 and 5 over 11. So that's how we find the transmission parameters or ABCD parameters for the given two-port circuit.